Hello to all my viewers. This is Dr. Dhaval Maheta, and today we'll understand how to run logistic regression in SPSS. Logistic regression is a statistical method used for binary classification problems, where the goal is to predict the probability of a binary outcome. Remember, dependent variable has only two levels. The example is yes, no, success, failure, users, non-users. So the prediction is done based on one or more predictor variables. Unlike linear regression, which predicts a continuous outcome, logistic regression predicts the probability of a categorical outcome, which is constrained between 0 and 1. Applications of logistic regression will start with the medical diagnosis. Logistic regression can predict the probability of a patient having a disease based on diagnostic features. For instance, it might predict whether a patient has diabetes based on factors like age, BMI, blood pressure, and glucose level. It helps in assessing the risk of developing conditions such as heart disease or cancer based on various health indicators. Finance and banking. Banks use logistic regression to assess the likelihood of a borrower defaulting on a loan. This is based on their credit history, income, employment status, and another financial metrics. It can be used to identify potentially fraudulent transactions by analyzing patterns and anomalies in transaction data. Marketing and customer analytics. Businesses use logistic regression to predict the likelihood of a customer leaving their service based on their usage patterns, interactions, and feedback. It helps in determining the probability that the customer will respond positively to a marketing campaign or promotion based on their demographics and past behavior. Resources and employment. It can predict the likelihood of an employee leaving the company based on factors such as job satisfaction, tenure, and performance metrics. Logistic regression is used to assess the probability of a candidate succeeding in a role based on their qualifications, experience, and interview performance. Epidemiology and public health. Researchers use logistic regression to model the spread of infectious disease and predict the impact of public health interventions. It helps in understanding the relationship between lifestyle factors and health outcomes, such as the effect of smoking on lung cancer risk. Sports analytics. Teams use logistic regression to predict the likelihood of a player performing well in game based on various metrics such as past performance, injury history, and training data. It can be used to predict the outcome of a match based on team statistics, player performance, and other relevant factors. So first, we will understand the concept of linear regression. In case of linear regression, for each value of x, we are having a unique value of y. So you can see here in linear regression, the blue dots. So on the basis of these blue dots, we are passing the red line. Now in case of logistic regression, for the values of x, the outcome can be only 0 or 1. So just here the blue dots now, all blue dots are at 1 or are at 0. So the function which can fit here, it's known as logistic function. The logistic curve can only fit here. So the logistic regression converts the output of the dependent variable to a binary outcome 0 or 1 through the use of the logistic function. The logistic function maps any real value number z into a value between 0 and 1. So we can the function will only give the output, will only give two outputs, either yes or no, 1 or 0. So to convert the probability p into binary outcome, a threshold is applied. If p is greater than or equal to 0.5, the prediction outcome will be 1, and if p is less than 0.5, the prediction outcome will be 0. Logistic regression converts the output of the dependent variable to a binary outcome 0 or 1 through the use of logistic function. Let's see how it does. So in logistic regression, we start with the linear combination of the predictor variables z is equal to beta 0, the intercept, plus beta 1 x1 plus beta 2 x2, and the last term is beta n xn. To convert this linear combination into a probability that ranges between 0 and 1, we apply the logistic or a sigmoid function. So P is equal to 1 upon 1 plus e. This is exponential constant. 1 plus e raised to minus z. What is z? This. We insert this values where e is the base of the natural logarithm. Please remember this formula. Logistic regression and odds ratio. Logistic regression model. It estimates the probability P of the binary outcome by modeling the log odds as a linear combination of predictor variables. Odds ratio provides a measure of how the odds of the outcome change with 1 unit change in the predictor variable. It is derived from the coefficients of the logistic regression model, where EB represents the odds ratio for the predictor Xi. Don't worry, I will explain all these concepts one by one. So we start with what is this odds ratio? An event can have two possibilities, success or failure. So the probability of success and the probability of failure. Now what are odds? The odds of an event is a way of expressing how likely an event is to happen compared to not happening. It's often used in statistics to describe the likelihood of an outcome. So the probability of the success divided by probability of failure. Let's consider one example. The odds of winning a game where the probability of winning is 0.8. So the probability of winning is 0.8. Probability of not winning is 0.2. So calculate the odds. What's the formula? P divided by 1 minus P. Success. Probability of success divided by probability of failure, 0.8 upon 0.2, which is 4. This means that the odds of winning are 4 to 1. For every 4 times you win, you would expect to lose 1 time. This is odds. So the probability and odds. Probability in terms of odds. So if I make P as a function, so P is equal to odds upon 1 plus odds. Odds in terms of probability. So odds is equal to P upon 1 minus P. This we have already seen. Now let's say the odds of a student passing an exam are 2 to 1. So odds is 2. Calculate the probability. So P is equal to odds upon 1 plus odds, 2 divided by 1 plus 2, 2 by 3, 0.667. This means that the probability of passing the exam is approximately 0.667, which is 66.7%. Now let's understand the odds ratio. Odds ratio is a measure used to compare the odds of an outcome occurring in one group relative to another group. It's commonly used in statistics, especially in logistic regression and case control studies, to assess the strength of association between exposure and outcome. If you have two groups, group 1 and group 2, and you want to compare the odds of an outcome between these groups, the odds ratio is calculated as follows. Odds in group 1. So odds 1 is equal to the success probability of group 1, the failure probability of group 1. So where P1 is the probability of the outcome occurring in group 1. Odds in group 2. Odds is equal to P2 upon 1 minus P2. Again, success divided by failure. Now how to calculate the odds ratio? So the odds ratio is equal to odds 1 divided by odds 2. So we will substitute their values, P1 upon 1 minus P1 divided by P2 upon 1 minus P2. Now let's understand this. Group 1, smokers. Probability of having the disease for the group of smokers is 0.3. Group 2, non-smokers. Probability of the having the disease is 0.1. Now let's calculate the odds. Odds 1 is equal to P1 upon 1 minus P1, 0.3 upon 1 minus 0.3. So 0.3 divided by 0.7, it is equivalent to 0.429. Now let's talk about this group. Odds 2 is equal to P2 upon 1 minus P2. So 0.1 upon 1 minus 0.1, 0.1 divided by 0.9 is 0.111. Calculate the odds ratio. OR is equal to odds 1 upon odds 2, 0.429 upon 0.111. It is equivalent to 3.87. Now, what does this figure mean? Let's understand. It is greater than 1. This indicates that the outcome is more likely to occur in group 1 compared to group 2. In simple language, smokers are approximately 3.87 times more likely to have the disease compared to non-smokers. Odds ratio less than 1. If this ratio was less than 1, it indicates that the outcome is less likely to occur in group 1 compared to group 2. Odds ratio equal to 1 indicates that the odds of the outcome are same in both the groups. So the odds ratio and its interpretation: if odds ratio is greater than 1, probability of success is more than the failure. If it's less, probability of failure is more than the success. If it is equal, event can happen in both the groups. Now calculate the odds ratio. This we have already seen. Now on the basis of this, we want to calculate the beta. So beta is equal to ln odds ratio. So the natural logarithm ln odds ratio, we will insert the values. So beta is equal to ln 3.87, which is equivalent to 1.35. So the logistic regression coefficient beta 1 for being a smoker is approximately 1.35. Now let's substitute these values. See, what is our logistic regression equation? Logit P is equal to beta 0 plus beta 1 into smoker. So if a person smokes, the value here will be 1, and if the person does not smoke, the value will be 0. We found out that the beta is 1.35. Let's assume that the beta 0 is equal to minus 2. So our equation is logit P is equal to minus 2 plus 1.35 into smoker. Naturally, if a person is a smoker, if I insert the value here 1, so the risk is 1.35 times more. It's so simple. Now convert the logit to a probability P. So P is equal to 1 upon 1 plus E raised to this minus beta 0 plus beta 1 into the smoker. This is the same thing which we discussed earlier, this one. Okay, let's proceed further. So if a person is smoker, logit P is equal to minus 2 plus 1.35 into 1. If a person is a smoker, so if we solve this, we get the value minus 0.65. So P, if we insert this value into this equation, we get the value 0.343. So the probability of having the health condition, the disease for a smoker, is approximately 34.3%. Okay. If a person is non-smoker, so we will insert the value 0. So logit P is equal to minus 2 plus 1.35 into 0, which is minus 2. So now let's solve this equation. We get 0.119. So the probability of having the health condition for non-smoker is approximately 11.9%. Interpretation of exponentiated coefficients. In your output, you will get exponentiated coefficient. So let's assume that the values can be 0.20, 0.50, 1, 1.5, 1.7. Now what you have to do, you have to deduct 1 from it. So 0.20 minus 1 minus 0.80. 0.50 minus 1 minus 0.50. This is 0. 1.5 minus 1, 0.50. 1.7 minus 1, 0.70. Now, what does this mean? This means decrease in odds ratio. This means increase in odds ratio. In case of logistic regression, our interpretation will be based on whatever we have coded as 1 in the dependent variable. Please remember this. Dependent variable can have 2 labels. Yes, no, success, failure, purchasers, non-purchasers, purchasers. Our entire interpretation will be based on what is coded as 1. So, what we will write? Let's say that this is contributing towards what is coded as 1, increase in odds ratio. And if it is negative, It is decrease in odds ratio towards 1. This you will understand in the example which we are going to take. So there is one case study. The goal of this case study is to examine the factors that influence the likelihood of HBATs. It's a hypothetical company. HBATs customers being located outside North America, which is a target variable X4 region customer location using logistic regression analysis. The analysis will focus on various customer perceptions and attributes related to HBATs products and services. So we are having two sets of customers, one inside the North America and second is outside the North America. And we want to see the perception of this customer based on the services which are offered. So we start with H6 product quality. Perceived level of quality of HBAT's paper products. This is H6. X7 is e-commerce activities and website. Overall image of HBAT's website, especially user friendliness. So we want to see what is the difference in the customers which are inside the America and outside the North America. Technical support, extent to which technical support is offered to help solve the product service issue. X9, complaint resolution, extent to which any complaints are resolved in timely and complete manner. Advertising, X10, perceptions of HBAT's advertising campaigns in all types of medias. Product line, depth and breadth of HBAT's product line to meet customer needs. X12, sales force image, overall image of HBAT sales force. X13, competitive pricing, extent to which HBAT offers competitive pricings. Warranty and claims, extent to which HBAT stands behind its product service warranties and claims. New products, extent to which HBAT develops and sells new products. Ordering and billing, perception that the ordering and billing is handled efficiently and correctly. X17, price flexibility, perceived willingness of HBAT sales representatives to negotiate price on purchases of paper products. Delivery speed, amount of time it takes to deliver the paper products once an order has been confirmed. So these are all perceptions and attitudes. What are the other variables? X1, customer type. So if it is 1, less than 1 year, 2, between 1 and 5 years, 3, longer than 5 years. Industry type, if it is 0, magazine industry, 1, newsprint industry. Firm size, please remember X3 and X4. Firm size, 0, small firm, fewer than 500 employees, 1, large firm, 500 or more employees. Region, customer location, 0 is USA, North America, inside North America. Please remember this. 1 is outside North America. So our entire interpretation will be 1 which is coded as outside North America. Distribution system we are not going to consider here. So let's go in SPSS dataset. So this is the same dataset which I am talking about. You can see it. And the perceptions have been measured on the scale of 0 to 10. 0 is poor, 10 is excellent. So we'll go and analyze regression, binary logistic, region. We will take it independent. It's a categorical, the binary outcome, yes or no. And we will select from X6 to X18. Transfer it here, save, probabilities and group membership, continue, options, Hosmer-Lemeshow goodness of fit, continue, style, keep as it is, no change, bootstrapping, nothing to change. Here, activate forward wall statistics. Now, click OK. And you got the results. So the dependent variable coding, the beginning block, and the variables in the equation. So first we will do the interpretation of classification table block 0, the null model. So the null model is the model in which the predictor variables are not at all considered. See, variables not in the equation. no independent variables is considered in the equation. Only we start with constant base model, null model. So let's say do the interpretation of classification table and variables in the equation. I have taken this thing on the slide. So this is the data. Okay. So we got the output 81,119. Now what is this classification table? Let's understand. This is the observed data, the original data, and this is the prediction done by the model. Okay, so we got without any predictor variables, the classification is 81 and 119. If you take the ratio of 119 divided by 81, you will get 1.469. Okay, and the classification accuracy is 59.5. Now, when we insert the predictor variables in our model, it is necessary that our classification accuracy goes above 59.5. It should be always better than the null model. The next is omnibus test of model coefficients. This you will get it from here. Here is it. Okay, let's understand this and how to interpret. We will see. Step 1, the chi-square is 79.452. Step 2, so some predictor variables are included in the model. So the chi-square is 36.938. Now you take the addition of this two, you will get 116.390. Again, take the addition of step 3, 14.762. So it is 131.152. Now, gradually what will happen? That the chi-square value will decrease. So adding more predictor variables will no longer improve your model. Okay, so we have to identify which model is better. Remember, these are the p-values and they should be less than 0.05. So what is the interpretation? When evaluating the improvement in the model fit between steps or blocks. So in step, which is the predictor variable which is inserted, and the block consists of all the predictor variables together. So the omnibus tests are used to determine if the addition of predictor variables significantly improves the model or not. Each step includes one or more predictors that are introduced in the model at a specific stage. This means that in step 2, variable x1 entered, just as it's an example. Block refers to the group of predictors that are entered into the model together. Each block represents a set of variables that are tested for their combined contribution to the model. Block consists of variable x1, x2. See, let's understand this concept. The step, which are the variables which entered? So x12, x13, x17, they were already present. x6 was entered. So that is a step. And together it is known as a block. Okay, let's proceed further. The next is model summary. So we get -2 log likelihood, Cox and Snell R square and Nagel-K R square. This output is available here. Here it is. Now how to interpret? Just a second. This is Hosmer-Lemeshow test. Yeah, this is model summary. Okay, -2 log likelihood, Cox and Snell R square and Nagel-K R square. Well, let's write the interpretation. -2 log likelihood. It represents the log likelihood of the model with the lower values indicating the better fit. As step increases, this value should drop. Is it dropping? Yes, it's dropping. You can see from 190.543 to 99.015. It's really good. Cox and Snell R square. So what is the interpretation? As you add more predictors, the -2 log likelihood should decrease, indicating that the model is improving in its ability to fit the data. Okay, Cox and Snell R square, an approximation of the proportion of variance explained by the model similar to R square in linear regression. Now, why we cannot use R square here? Because Y is not continuous. Y is categorical. So instead of the R square, we are using pseudo R square. So it is calculated based on the likelihood ratio and tends to be smaller than the Nagel-K R square. These values will be always smaller than Nagel-K R square. So Nagelkerke R square is an adjusted version of Cox and Snell R square that adjusts for the maximum values of Cox and Snell R square. It provides a more interpretable measure of how well the model explains the variance, with values closer to 1 indicating a better fit. So the R square values are increasing, really nice. These values are also increasing. This is also nice, and it is nearer to 1, which is quite good. Now let's proceed for the next test, which is Hosmer-Lemeshow test. This is generated here. Okay. Now how to interpret this test? We always go from bottom to top. The Hosmer-Lemeshow test is a statistical test used to assess the goodness of fit for logistic regression model. The Hosmer-Lemeshow statistics indicates a poor fit if the significance value is less than 0.05. Okay, if this value is less than 0.05, this means that this model does not fit the data appropriately. Step 7 model is poor fit to data as its p-value is less than 0.05. So model is invalid. So we will proceed on the top. We always move from bottom to top. Step 6. Step 6 model adequately fits the data than step 7 because the significant value of step 6 model is 0.247, which is more than 0.05. So the model is valid. So stop here. The next is the classification table. So this is generated here. Here is a classification table. How to interpret this table? Let's see. We'll start with step 1. The original data. USA, North America, and outside North America. Now the prediction done by the model USA, North America, and outside North America. So 52 are such cases in which the prediction was correct. The prediction done by the logistic function was correct. So the prediction was USA, North America, and the original data is also USA, North America. Now 99 are such cases in which the original data was outside North America and the prediction done was also outside North America. It means that diagonally these values specify, diagonally this describes that the classification has been done correct. So 52 plus 99 is a correct classification. Now let's understand this part. Outside North America 20, prediction done by the model inside North America. So this is wrong. Let's see this one. Inside North America, prediction done by the model outside North America. So 20 plus 29, 49 are misclassified cases, also known as a leakage in the model. Now let's see for step 6 and step 7. Step 6 model, overall classification accuracy of this model is 86.5%. This figure, how we got it? 71 plus 102 divided by 200, the total number of cases, indicating a high level of predictive accuracy, meaning that the model is effective in distinguishing service complaints between the two regions, or between distinguishing the perceptions between the two regions. So I have changed it. The model is effective in distinguishing perceptions of customers between the two regions. Step 7. Overall classification percentage is 88.5. So it's the highest among all steps. But we will select step 6 model as the Hosmer and Lemeshow test supports the model's adequacy with a p-value of 0.247, indicating that the model is well calibrated. See, here classification accuracy is high, I agree. But Hosmer and Lemeshow supports the step 6 model. Okay. The next is variables in the equation. So it's here. Okay. So first we will interpret the Wald statistics. Wald statistics is equal to beta square, this one, beta square, divided by standard error square. So we will get these values. A high Wald statistics suggests that the predictor variable has a strong relationship with the dependent variable. This often corresponds to a small p-value, meaning you can reject the null hypothesis that the coefficient is 0 and conclude that the predictor significantly affects the outcome. Let's see step 6 model and the Wald values. Yes, they are higher. And just see the p-values also. Here is it. They are. All the p-values are less than 0.05 in step 6. So which are the predictor variables which are significant? X6, X7, X11, X12, X13 and X17. Remember how to interpret this. See, this is beta, okay, and this is exponentiated beta, okay. So what we will do, we will deduct 1. I've already explained this. From this values exponentiated beta, we will deduct this, and our interpretation we will write on the basis of increase in odds ratio or decrease in odds ratio, and that also what is coded as 1. 1 is outside North America. See the coding. 1 is outside North America. So now we'll write the interpretation. Constant term is minus 5.056. There is a log odds of a customer being outside North America. X4 is 1 when all the variables are 0. So the log odds of customer being outside North America when all the variables are 0. Why we are writing this way? Because our interpretation is based on what is coded as 1. I am repeating this thing again and again. Now let's talk about the product quality beta 6, X6. It is minus 0.679. Minus 0.679. The coefficient minus 0.679 means that for each unit increase in perceived product quality, the log odds of customer being outside North America decreases by 0.679. Okay. So what we write? Log odds of customer being outside. Log odds decreases. Decrease in odds ratio. Okay. The perceived product quality increase is associated with the decreased likelihood of being outside North America. In other words, better perceived product quality tends to be associated with being located in USA, that is inside North America. The odds ratio of 0.507 indicates that with each unit increase in perceived product quality, the odds of being located outside North America are halved. How? 0.507 minus 1 into 100. Just recall this, okay? Exponentiated beta minus 1. So we get 49.3%. Next, X7, that is e-commerce. This coefficient is also negative. It indicates that for each unit increase in e-commerce, the log odds of customer being outside North America decreases by 1.556. A better image of HBAT's website is associated with the decreased likelihood of being outside North America. The odds ratio of 0.211, this one, means that for each unit increase in the perceived user friendliness of the website, the odds of being located outside North America decreases by about 0.211 minus 1, so it is 78.9%. Next, product line, that is X11 beta 11. This is also negative. The coefficient, so let me change a little bit. The coefficient minus 0.630 means that for each unit increase in the diversity of the product line, the log odds of customer being outside North America decreases by 0.630. An increase in the perceived adequacy of the product line is associated with the decrease in the likelihood of outside North America. The odds ratio of 0.532 indicates that with each unit increase in product line diversity, the odds of being located outside North America are reduced by about 46.8%. How? 0.532 minus 1 into 100. Sales for image, beta 12. 2.245. Now the interpretation will change. Okay. The coefficient 2.245 suggests that for each unit increase in perceived sales per image, any guesses? The log odds of customer being outside North America increases, not decreases, increases by 2.245. A better sales for image is associated with the increased likelihood of being outside North America. The odds ratio of 9.438 means that with each unit increase in sales for image, the odds of being located outside North America are increased by about 9.438 minus 1 into 100, 843.8 percentage. So this is a very significant predictor variable, very significant. Competitive pricing, beta 3, x13, 0.504. The coefficient 0.504 indicates it is positive that for each unit increase in competitive pricing, the log odds of customer being outside North America increases by 0.504. Better competitive pricing is associated with an increased likelihood of being outside North America. The odds ratio of 1.655, this one, implies that with each unit increase in competitive pricing, the odds of being located outside North America increases by about 1.655 minus 1, so it is 65.5 percentage. Next, price flexibility, 1.374. The coefficient 1.374 means it is positive that for each unit increase in price flexibility, the log odds of customer being outside North America increases by 1.374. Greater price flexibility is associated with the increased likelihood of being outside North America. The odds ratio of 3.950 indicates that with each unit in price flexibility, the odds of being located outside North America increases by about 295 percentage, which is 3.950 minus 1. Okay. So what is our conclusion? In this logistic regression model, factors like sales for image, price flexibility, and competitive pricing significantly increase the likelihood of the outcome, that is customer being located outside North America. On the other hand, higher product quality, a better e-commerce experience, and a more comprehensive product line are associated with the lower odds of the outcome, that is the customer being located outside North America, it is inside North America. So lower odds means customer being located outside North America, the odds are less, so the customer is inside North America. These insights can help HBAT tailor its strategies to different customer segments based on their geographical location. Now, what is the equation which we have made? So it is based on this one, x7, step 6, x6 multiplied by 0.679, x7 minus 1.556, x11 minus 0.630, x12 into 2.245, x13 into 0.504, x17 into 1.374. You can see here it's the same equation. So logit P is equal to this equation. Now let's see, we feed the new data to this equation. The new data is, we got the observation x6, x7, x11, x12, x13 and x17 and their values on the scale of 0 to 10 for a new customer. And let's predict the location, that the customer is inside the North America or outside the North America. So the logit P is equal to minus 5.0556, the constant, plus minus 0.679 into the product quality 8, that is 8.7, plus minus 1.556 into e-commerce, which is 3.2, minus 0.630 into 4.6, plus 2.245 into 4.8, plus 0.504 into competitive pricing 2.7, plus 1.374 into price flexibility 6.8. Let's solve it. So logit P is equal to 2.6295. So we got the probability P is equal to e raised to 1 plus e raised to. So we have solved. This is a sigmoid function from where we started. So we got the probability is 0.933. What does it mean? For observation 1, the probability of being located outside North America is approximately 99.86%. So this is a high probability. It means that it is contributing towards 1. This extremely high probability suggests that the given provided values for product quality, e-commerce, product line, sales for image, competitive pricing, and price flexibility, the customer is very likely to be based outside North America. Now it will give you the probabilities. We'll go in the data view, go at the fag end. Here are the probabilities. See. So the high probability outside North America, low probability is inside North America. Now let me drag this prediction done by the model to the original database. Here is it. So these are the original values and this is the prediction done by the model. For first case, original outside North America, prediction done outside North America. So this is correct classification. Inside North America, this is correct classification. But let's talk about the third case, outside North America, and the prediction done is inside North America. So this is misclassification. So this is one type of misclassification. Second type is here it will be USA North America and here it is outside North America. That also we will identify. So here is it, USA outside North America. Now let's introduce one categorical variable. We'll again go into the data. Variable view, firm size. I told you to remember this. What is coded here? Let's see the coding here. 1 is large firms and 0 is small. 1 is large, 0 is small. Now how to introduce a categorical variable in logistic regression? Activate this logistic regression and transfer x3, the firm size here, and go into categorical, and x3 is to be transferred into categorical covariates, and click continue and click OK. Now you will get the another output. So just see the step 6, firm size 1. Okay, firm size 1, the value is minus 2.852. Okay, now let's write the interpretation. So here it is, okay, minus 3.322. Anyway, we'll write the interpretation according to this only. So if a company, just a minute, let me check in the output. In step 6 model, it is, yeah, I was referring step 5. Sorry, we have to refer step 6 model because according to the Hosmer-Lemeshow test, we are working on step 6 model. This is minus 3.322. Now let's write the interpretation. If a company has more than 500 employees, large firm, it is coded as 1. The log odds of being located outside North America decreases by 3.322 compared to a company with 0 to 499 employees. Why we are saying log odds decreases? See, what will be the value of firm size? Either it can be 1 or 0. So if it is 1, so firm size into minus 3.322. So the log odds decreases. If this is 0, so 0 into minus 3.322, right? So that's the reason we write. Again, we repeat. If a company has more than 500 employees, which is coded as 1, the log odds of being outside log odds of being located outside North America decreases by 3.322 compared to a company with 0 to 499 employees. The odds ratio of 0.036 suggests that large firms are much less likely to operate outside North America compared to smaller firms. The p-value indicates this effect is highly statistically significant. So this was all about how to run logistic regression in SPSS. For more videos on advanced data analysis using SPSS, kindly subscribe to my channel. You can also refer my playlist in which I uploaded videos on data science, machine learning, and artificial intelligence. Please don't forget to like and share my videos. You can also follow me on different social medias, link given in the description box.